So I welcome you to the lecture series on practical image processing using OpenCV Python. Myself, Dr. Bora, and today our topic is how to denoise an image with cv.fastNlMeansDenoisingColored method. Well, as you have seen that we are discussing about the different image restoration techniques. So this particular practical session will be one of them, and here we'll go through the same in practical implementation of the NL means denoising method. Okay, so before starting the practical, I want to tell you some informations which are very important for you. So let's start now. So up to now we have discussed different image smoothing techniques like Gaussian blurring, median blurring, and we seen that they are good to some extent in removing small quantities of noise. You should note down that those image smoothing techniques are good only to remove some extent of noise. In those stock techniques, what we did, we took a small neighborhood around a pixel and did some operations like Gaussian, weighted average, median of the values, etc. to replace the central element. In short, noise removal at a pixel was local to its neighborhood. There is a property of noise. I hope you have already know about that fact because I have discussed that in my theoretical digital image processing classes. Okay, that is a parallel lecture series going on to discuss the different technical terminologies behind those computer vision techniques. So, noise is generally considered to be a random variable with a zero mean. Note down this point that noise is generally considered to be a random variable with zero mean. So, consider a noise pixel p is equal to p naught plus n, where p naught is the true value of the pixel and n is the noise in the pixel. Then you can take large number of same pixels from different images and compute their average. Ideally, you should get p is equal to p naught since mean of noise is 0. Note down, mean of noise is 0. So ultimately, you will come up with p is equal to p naught. So you can verify it yourself by just a simple setup. What you do, just hold a static camera to a certain location for a couple of seconds. Static camera means you can take your own means smartphone camera also, and this will give you plenty of frames or a lot of images of the same skin. Okay, then write a piece of code to find the average of all the frames in the video, and this should be too simple for you now. You already know that how to write that code. Okay, I have discussed in my lectures. Then compare the final result and the first frame. You can see the reduction in noise, but unfortunately this simple method is not robust to camera and screen motions. So also often there is only one noise image available. Got it? So idea is simple. We need a set of similar images to average out the noise. Consider a small window, say a 5 cross 5 in the image, then chances large that same page may be somewhere else in the image, sometimes in small neighborhood around it. Then what about using the smaller similar species pitches together and find their average? Consider this image below. Okay, the blue patches, you see these blue patches? This looks similar. Then green patches, you see these green patches? They look similar. So we take a pixel and take small window around it, search for similar windows in the image and average all the windows and replace the pixel with the result, what we got. And this is known as our non-local means denoising. Yeah, it takes more time to compare to those different blurring techniques that we have discussed, but result is too good. Okay, and in case of color images, the image is converted to scilab color space and then separately denoise the L and AB components. Clear? So that's what I want to discuss before starting the practical session. So today we are going to deal with one such non-local means denoising techniques. That technique is cv.fastNlMeansDenoisingColored. And we have several parameters. The first one, deciding the filter strength. Higher the H value removes the noise better, but removes details of the image also. So 10 is okay, but don't go for greater than 10. Okay, in that case, you may lose some image details also. Then H for color component will be same as H, but for color image is normally same as H. Okay, then template window size should be odd. That is, 5, 7 like that. But recommended one is 7. Then search window size should be odd. Recommended size is 21. And the code for this one is take a screenshot of this. Okay, so import cv2. You know why I'm importing this cv2, because we are doing in OpenCV. Then from matplotlib, import pyplot as plt. Then import your input image, a image where suppose Gaussian noises are affecting it. Okay, in my case Lina 512 color. Then this dst, this is the output image where I have stored my noise free image. Okay, for this fast nl means denoising colored method, image non 10 10 then 7 21. Okay, then you can apply this subplot function. In that case, the original image, this one image, and this noise free image, that one will be shown in the same plot. So we are creating two subplots, then this will be shown. Or you can show the image through the methods that I have been discussing from the last lecture, that the cv2 image show original image, then cv2 image show noise free image dst. So cv2 wait key 0. So main important function, this cv2 fast nl means denoising colored image non 10 10 7 21. The parameters are being discussed here. You can take a screenshot of this one. Also, we have taken the Windows template size as 7 and the search window size as 21. Okay, so come now open your spider. So this we have opened the spider. So we have written the code that I have just shown to you. Then run this file. The file is running. Okay, so you can see that in that console portion. So it may take few minutes of time, as I have told you that it takes longer time than that smoothing operation. Yeah, see, the output is coming in the subplot form, but I want to show you in the original image form. That is, this one is the original image and this one is the noise free version. So you have seen that the Gaussian noise being removed through this nl means functions properly. Okay, you can go through various operations of the same image with different value of the parameters in that nl means functions. Okay, so I hope you have understood what I have discussed in this lecture. These are very important point for you. And coming to the today's question is, what will be the mean of noise? Okay, what will be the mean of noise? And in default case, what type of noise may be removed or reduced with this NLM, NL means denoising colored functions? What type of noise can be removed using fast NL means denoising colored method that I have discussed today?